Welcome. We are currently experiencing a proton event that started yesterday, and now hopefully that I've solved my computer problems I can tell you about it. I always wonder if such computer problems are associated with increased solar activity, but I expect it's a coincidence, though a computer repair guy did say once that he always gets more calls when the sun is active. I think that's an excuse for the crappy computers they supplied us with. But first, our trivia question. 46 years ago today, France became the third nation to launch its own satellite into orbit. What was the name of that satellite? Let's take a look back over the week and see what the sun has been up to. As you can see from the GOES X-ray plot, we've had lots of flares, but we've experienced no major flares, which I define as M-class or above. Over the week we've had a total of 38 flares, and the X-ray background has steadily fallen. This compares to the previous week of 47 C flares. While 47 is statistically indistinguishable from 38, but last week had 3 M flares which made it much more active, so we could conclude that the solar activity has been waning slightly. Will that downward trend continue? Only time will tell. However, I forecast the next major burst of activity will not occur until March, plus or minus a month. That doesn't mean we won't get any flares in the meantime, it's just that things will quieten down for a while. However, the wild card in this is the southern hemisphere, which has not really gotten underway as yet. I forecast about 6 months ago it would start up in December plus or minus 2 months, so we've already entered that window. So I'm expecting it to start any day now. Now we'll use the evolution of the sunspots and coronal activity to see how we can get a better idea of what's going on. First, the sunspots. This clip is using the AIA 4700 angstrom band. You can see that the week started off with some nice spots in the south, and I was already to start crowing about my forecast, but the regions died away quickly, and now we've reverted to the more familiar string of large spot groups in the north. Let's now take a look at the transition region from the SDO AIA Helium 2304 channel, which is particularly useful for seeing surges of jets and eruptions. The big news here is the eventual eruption and disappearance of the so-called superfilament in the northwest a few days ago. Quite spectacular. Next we turn to the low temperature corona with the Iron 9 171 channel. And here we're looking for interconnections and the formation of loop arcades, signaling the launch of coronal mass ejections as the coronal loops reform and cool after the CME has passed by. Last we look at the high temperature corona in Iron 20 at 131 angstroms. This channel shows the sites of flaring. Each flash here is a flare and has produced at least some 10 million degree plasma. This is common at the earliest stages of flares as stress magnetic fields reconnect and rearrange themselves, releasing energy in the form of heat and mass motions. Before leaving the sun, we should look at the coronal mass ejections that have been launched into the interplanetary space as a result of these flares. As you can see, we've had quite a few beautiful CMEs in the last week. However, how many of them are geo-effective, i.e. hit the Earth and produce a geomagnetic storm? Remember, CMEs can hit the Earth and have no effect at all. Their geo-effectiveness depends on many factors, only one of which is their trajectory. It is what is called in science a necessary but insufficient condition. Meanwhile, Geospace has been very quiet over the week, so none of these have been geo-effective. However, I think that is about to change, as we shall see in a minute. Before we get into what has happened in the last 24 hours, let's take a look at the status of the solar cycle. Here is the unreliable sunspot number, which is unfortunately used by many to measure the solar activity. You can see that until last month it was lagging behind the models, the red line. The recent spike of activity has taken it well above that prediction. Will that trend continue and so we will have a more active cycle? Who knows? The answer is nobody knows. The model is predicting a peak of solar activity in 2013, so we have 18 months to get to solar maximum. I have often been asked about the sun being so active, usually after a major flare and when the usual crop of doom and gloomers come out of the woodwork forecasting disasters in 2012. Let's compare the X-flare rates in the current cycle with the previous 3 cycles and see how active we have been. So far this year we've had only 8 X-flares. This apparently worries some folks. It shouldn't. Typically we have been having as many as 150 X-flares in the cycle. Though there looks to be a slight downward trend at the moment, which probably is not real, we should expect at least 100 more X-flares over the next 4 to 6 years. We could have as many as 50 X-flares next year, and that would not be anything out of the ordinary. so ignore protestations of impending disaster, at least from the Sun. Now let's turn to what's been happening in the last 24 hours, and in particular focus on our Proton event. In the X-ray plot there seems to be nothing particularly spectacular going on. There is a long duration flaring starting at 600 UT yesterday, and that turns out to be the origin of the protons, which is odd because normally we associate proton flares with large impulsive flares, not tiny events that barely make it to the sea level. So why is this event so proton rich, yet X-ray poor? Let's take a detailed look at the region that produced the event. It was in the northwest. First the helium-2 channel, and we see the eruption to the south, formation of a two-ribbon flare immediately thereafter. You may recall I discussed two-ribbon flares in my video on the 9th of November. Note this event takes place well away from any active regions, so we can't draw on the strong stress magnetic fields that the sunspots provide, hence the weak X-ray signal. The other point here is, being in the northwest, it is perfectly situated to impact the Earth. More on that later. In the low corona you can see the same event, and sometime later the post-flare loops form. These are what produce the long duration C flare, not the initial flare, which is very faint by comparison. Next we turn to the iron 16 channel at about 2.5 million degrees. Here again you see that the X-ray loops form, but they are not very bright, and cover a large area. They last for a long time, which puts the long in long duration event. Last we look at the high temperature iron 20 plasma, and although the event is just visible, it would hardly be a matter of interest unless we had the proton event and the CME associated with it. So let's take a look at the CME. Here is a composite of the Soho-Lascaux C2 and C3 fields of view. As you no doubt can see, it is quite spectacular and out of all proportion to the flare. I think this is the origin of the myth that many CMEs are not associated with flares. It's just that the flares are very faint. But the question is, will it be geo-effective? The fact that the CME is a halo event implies that there is a possibility of it's going to head towards the Earth. If we take a look from the side view from Stereo A spacecraft, the Earth will be on the left in these images. You can see that the radial trajectory will put the Earth in the danger zone for the most intense part of the storm. But orbits are three-dimensional. If we look down on the top of the Sun and place the CME on the western side of the Sun, then the radial trajectory will carry it past the Earth. But in this plane, the trajectory is not radial but spiral, as CMEs mostly follow the Sun's magnetic fields, which form a spiral. When you include the correct bend in the Sun's magnetic field, it puts the Earth right back in the danger zone. The more complex Nil model basically confirms this, so we can expect a geomagnetic storm in the next 1 to 3 days. But the severity is unclear, as it depends on so many other factors, most of which we don't know until the event starts. By the way, I am re-recording this on Sunday morning after the computer disasters of yesterday. I note that an almost identical event seems to be in progress as I speak. I've not yet found out where or what it is, but if it turns out to be important, I'll issue a breaking news item later. On that cheery note, let's take a look at the sunspot regions. We currently have 9 numbered regions on the disk. They've been generally stable or decaying, which explains the lower level of flaring activity. Let's start with regions 1352 and 1354 in the southwest. They've produced no flares in the last 48 hours and have been in a steady decay for the most of the week. Next, regions 1353 and 1359 in the northwest. Region 1353 produced a C flare, but is also decaying. However, 1359 has recently started to grow rapidly and produce 2 C flares, but unfortunately it will disappear over the west limb in the next day or two, so will not influence our space weather until it returns over the east limb in a couple of weeks. Regions 1355 and 1356, which are just west of Sun Center, are twins, being large, relatively isolated spots that are slowly decaying. They have not produced any flares recently. We don't have any history on region 1360, but it is a large, rapidly growing complex group, and is worth keeping an eye on. Region 1358 has also been rapidly growing and has produced a C flare, and is another candidate worthy of attention. Its small companion region 1361 has only recently been identified, so we have no history on that. As indicated earlier, the solar wind has been relatively quiet, but is forecast by NOAA to pick up a little due to the coronal hole moving into a geo-effective zone in the western hemisphere of the Sun. Plus, the CME makes me think we might get at least minor storm conditions in the next few days. However, the auroral zone has been quiet, and the KP index, a measure of the stability of the Earth's magnetic field, has been very quiet also. So in summary then, the sunspot number is at 171, the radio sun is at 135 solar flux units, the solar wind speed has dropped to 365 km per second, the X-ray background is low at B4, and the KP index is quiet at 1. If you want to find out more about the Sun, please follow some of the links in the description box below. If you like this and want to see earlier editions of the Sun today, go to my channel, they're all listed there. If you want to stay up to date on what's going on in the Sun, please subscribe, you're welcome to do so. The answer to our trivia question is Asterix 1, was the name of the first French satellite. That's it for today, keep safe, bye for now.